Welcome to educational channel. So this video I'll explain you the fundamental concepts and some operations on algebraic expressions. So each and every concept from especially for class 8 students, ICSE board and other boards also will be helpful. So each and every topic briefly I'll explain throughout this lesson. So before that, not only this video, so if you want the questions which are related to this topic from class 8 and other classes, other subjects also, I am providing one website here, and you can see the link in description below also. Otherwise directly you can click on this, means this website you can click. So in that class wise, subject wise, topic wise also materials, test papers are available. So you can go through the website and other informations also freely you can see from that. And subscribe the channel because you'll upload only videos which are related to the education type, for only especially useful for students. Fine. Okay, now let's begin this topic. So fundamental concept and algebraic expressions. So first of all we need to know little basic concepts on this algebra, so algebraic expressions. So in arithmetic we deal with quantities which are denoted by figures, right, that have single definite value. But in algebra we deal with quantities which are denoted by symbol, and that is alphabet and letters also. We may have more than one value, so we'll see each and everything. First of all, in this concept you must know about constant. Okay, what is constant? Now let's see. A symbol having a fixed numerical value is a constant. A symbol, this letters, having a fixed numerical value is called constant. So fixed numerical value. Now example, if I take this 7 comma minus 2, okay, 3 by 8. So a symbol having a fixed numerical value is called constant. Now 7 is a fixed value it is, and negative 2 is a fixed, 3 by 8. Okay, not only this, irrational numbers 2, 3, pi, 2 root 2. So some fixed value, these are all nothing but constant. So here 2 root 2 is multiplied, this is cube root of 2. So anything you can take, this is all fixed value which are constant. Now variables or literals. So these are all fundamental basics we'll use in this chapter one by one. Variables or literals, you must know about these terms first, then you can understand the topic easily. So variables, or we can call literals also. Okay, what is variable or what is literal? A symbol which takes in various numerical values is known as variable. So any symbol which takes on various numerical values is known as a variable or literal. This is definition, I am not writing here. So for example, if you take 4a, so in the place of a we can take any value, right? For example, p is equals to 4a. So p is a variable, but we can fix it by, in the place of a, if we keep any value, then it will be changes. So we know that the perimeter of the square of the side a is 4a. Here 4 is a constant, okay, but a and p are the variables, because according to a the p value will be changed. So which will never changes, that is constant, but we can variable means a and p. Okay, a, p are literals or variables. So variables is nothing but which takes on various numerical values is known as a variable or literal. So we can keep any letter. Perimeter is the total length of the boundary. Now if it is side is 2 meters, then perimeter is equals to 4 into 2. So in the place of a I am keeping 2, that is 8. So p value become 8. So these are the variables or literals. So now what is algebraic expressions exactly? So if you want to see, combination of constants and variables. Now constant we have, I explained you, and literals or variables. So algebraic expressions nothing but a combination of constants and variables. Now for example, 4 is a constant and x is a variable. So combination connected by operations plus, minus, into, divide by is known as algebraic expressions. Now 4x is a term. This term is combined of constant and variable. Now 3x square is connected with positive number with some another 3x. So like this combination. So algebraic expression is nothing but the combination of constants and variables connected by operations like plus, minus. So 3x minus 2 is all under algebraic expressions. Now terms of algebraic expressions. So what is term? Now if I write, for example, I'm writing an algebraic expression 3x square plus 4x plus 5 or minus 5. So like this, one example I have taken. Now in this 3x square is a term, 4x is another term, and 5 is another term. There are three terms combination. So several parts of an algebraic expression separated by plus or minus sign are called the terms of the expression. Okay, example, if you see terms of expression means 6a plus 7b. Okay, is an expression is containing two terms, right? The terms are 6a and 7b. This is one term and this is a term. And one more example, if you see, these all terms of an algebraic expression. Now 7 plus 5x minus 8xy. So every term need not be constant and variable compulsory. So only 7 is a constant. This is also one term. 5x is in a term. And 8xy. This is all separated by plus or minus. Okay, the several parts of an algebraic expression separated by plus or minus signs, the symbol, are called terms of algebraic expressions. Okay, any example you can take. I'll show you one more example, last one. For example, taking four terms, 3x 5, that means x is only multiplied by 5 times and 3 is multiplied with that, minus 2x power 3 plus 6xyz minus 8z cube. So this is an expression. This is an expression, algebraic expression. So which contain how many terms? 4 terms. There are 4 terms, right? So namely that is 3x power 5. So the 4 terms are, this is one term, and minus 2x cube, 6xyz, and minus 8z cube. These all are adding. So adding with negative or positive. So now these all terms. So term is nothing but combination of numerical value and literal variable. Otherwise only single. Only if I take x also is called term. X is nothing but before there is nothing means 1 it is. So it's 1 into x. So 1x. So you not write 1 into x always, just will keep x. Okay, 3x. So 3 is multiplied by x. These are all the terms. So terms of algebraic expression. The several parts of an algebraic expression is separated by plus or minus sign are called terms of the expression. Now this is the way we can see the algebraic expressions and constant and literals and what is variable. Okay, next we will see various types of algebraic expressions. So algebraic expression I explained, that is combination of constant and variables connected by plus, minus, into, divide by sign. Now how many types are there? Various types of algebraic expressions. So how many types are there? How to define them? So how to use them in the problems? I'll explain you now. So various types of algebraic expression. So what is algebraic expression? Already explained you. The combination of constants and literals or constants and variables connected by plus, minus, into, divide by sign. Okay, that is algebraic expression. For example, 5x is a term, is connected with 3x square. So this is an algebraic expression. Otherwise 3x cube is a term, is connected with minus 2xy. This is also connected with some plus 4x square. Now this is also an algebraic expression. So how many types are there in this? So we'll see one by one. First type is, okay, so first one, monomial. Monomial. So the word itself says mono, means single. So an algebraic expression containing only one term is called monomial. So mono means only one. So an algebraic expression containing one term only. So only one term is there, that is called monomial. So it is only one term. So algebraic expression which contains only one term is known as called monomial. So example, only one term means 5x is only one term. Okay, minus 6x square is a term. So term is nothing but combination. Again, numerical value and constant, otherwise single. And minus 28. This also is a only single term. So it's also monomial. And 43. Okay, 43 by 7ab. Some combination, letters and number, numerical value, constants, including denominator place also. This also term. So these are all monomials. Okay. Now second type is binomial. So in binomial, the word itself says bi, bi. Bi is bi means it's a two. So combination of two. An algebraic expression containing two terms. So it contains only two terms is called binomial. So there are two terms should be there. Now only two terms. So there should be two terms combination is binomial. So let's see example. Okay, combination of two terms. I am taking, okay, 5x is one term and 3x square is another term. I am combining with plus. That's it. So this is a binomial having two terms, namely the 5x and 3x square. Now one more example, if you see 2xy minus 3 by z is also binomial having two terms. And there should be different terms. Variables are same, different. So 5x and 3x square, 2xy minus 3 by z. This is all binomial. If I take x plus y plus z, so this is not binomial because 3 are there. So this is not a binomial. Only an algebraic expression containing two terms is called binomial. Fine. Next, if you see third one. So 1, 2 are over. Next to 3. 3 means we can write the word tri. Because triangle, triangle, trinomial. Okay. Monomial, binomial and trinomial. It's easy to remember. Right? An algebraic expression containing three terms. Tri itself, the word says 3. So if there are combination of three terms, is containing three terms is called trinomial. Okay, let's see the example for this. Same like binomial, how we have seen, trinomial, but three terms combination. So what I said, x plus 2y minus 3z is a trinomial having three terms. So namely, what will say x, 2y and minus 3z. So the terms are x comma 2y comma minus 3z. These are combining with positive plus. These are the examples for trinomial. And you can write z square minus 2x by y minus 27 by 2. So something like this. So anything, there should be three terms. Here namely z square minus 2x by y minus 27 by 2. These are the three terms. So monomial, binomial and trinomial. Next is more than 3 if it is, that we can call multinomial. There is a fourth part, fourth type. Next one is multinomial. Multi means many, right? You know. So multinomial. So an algebraic expression containing more than one term is called multinomial. So not only exactly 2, 3 also. If it's two separate name we have binomial, 3 means trinomial. So more than 1 is called multinomial. So even if it is a binomial, trinomial example also, we can call multinomial. So more means should be more than 1. So more than 1. More than one term is called multinomial. So consequently binomial, trinomial are also multinomial. That also need to remember. You not to get confused. Even binomial, trinomial also multinomial only. You can take that example also under command of this. You can take examples 3 by 19 x square plus 3x minus 4z plus 5z square, something like this. So here 1, 2, 3, 4 terms is a multinomial. And even take 2 terms, 3 terms also is called under multinomial. Okay, these are the simple things: monomial, binomial, trinomial, and multinomial. So more than one term is all come under multinomial, and consequently we can call binomial, trinomial also multinomial. That also need to remember. Okay, now I will tell you some common errors and important facts also in this algebraic expressions. If you see some important common errors, for example, when you write 4xy, this also same as 4yx. Okay, this is the first one. The order of the variables in terms of algebraic equations does not matter. 4xy is nothing but equal to 4yx, or that is equal to xy4. Okay, that is one. You need to remember this. So these are some common errors. And 2x plus y is not equal to 2xy. Okay, 2x plus y is not equals to 2xy because 2x is adding with y. Here 2xy are multiplied. Okay, you should not take that. And similarly, if you observe this 2x square y is not equals to 2xy square. So why? Because if you observe, x square means x is 2 times and y is single. But here y is 2 times, y square, x is single. That's why they both are not equal. So you should not get confused when you are doing the problems and writing the terms. They are the important things you need to remember. And I can take anything. For example, if you take 2x square y, we can write as 2y x square, as I said previous. Okay, these are the simple basic common errors and important facts you need to remember which is correct and which is not correct. Okay, these are the type of various types of algebraic expressions. And next we'll see what is the factor and what is the constant term, coefficient, like terms, unlike terms also. I'll explain now. So factors of a term. So first of all, you should know about the factors. When you take number 12, so 12 is a number. I can write product of two numbers this. So 1 into 12 or 2 into 6. Again 3 into 4, right? 4 into 3. It's repeated. Now 1, 2, 3, 4, 6, 12. These are all the factors of this 12. Okay, 1, 2, 3, 4, 6, 12. So these are the factors of this 12. Similarly, when you come to the algebraic expression, for example, 2xy is a term. So in this, every one means 2 is a factor for xy and x also is factor, y also is factor. So we can say the definition like this. When two or more quantities, okay, numbers and literals, a number is 2, literals are x and y, are multiplied to form a term, then each one of these quantities is called factor of the term. Each one. 2 is also factor, x also factor, y also factor. Okay, when the combination of numerals and literals. Now 3x y square is a term. So in this factors are 3, x, y. So these are the factors we can say. And when you compare this, in this again numerical factor and literal factor also. So for example, I'll say example. Numeral and literal we'll see. So when you take example of minus 7x square y, minus 7x square y. So in this, the numerical factor is minus 7. So numerical factor in this minus 7x square y. So numerical factor is equals to minus 7. And when we compare, literal factors are x square y, xy, x square y. These are all combinations. So when you come to the literal, because 7 is not a factor of any other, that's it, only minus 7. But when you take the literal factors, so literal or variable, so when you come to literal factor, x individual you can take as 1 and x square, okay, y, x, y and x square y, these all come under literal factors. So for any example, so numerical we can divide and literally also we can separate it. So these are the factors of a term. Fine. Next you see the constant term. These are the numerical factor and literal factor. Now constant term. So when you take about this constant term, the term which is having only one constant, in the word only the meaning is there. An algebraic expression, a term which has no literal factor is called constant term. Okay, there is no any literal factor for any term. There is nothing but constant term. For example, if you take an algebraic expression x square plus y square plus xy minus 3. So this is actually combination of 4 terms. But in this constant term is no literal, that is only minus 3. So this is only the constant term. Okay, it's clearly we can say in an algebraic expression, a term which has no literal factor is called constant term. Now coefficients. Coefficients we'll see. So in coefficients, any factor of a term is called coefficient of the product of all remaining factors. So this is clearly need to understand. Any factor of the term, now previously you have seen many factors, is a coefficient of product of all the remaining factors. Now for example, I'll take 7xy is a term. In this numerical coefficient is 7. Numerical coefficient means only number, it's constant. So numerical coefficient is equals to 7. So in this term, a numerical factor attached to the variables is called numerical coefficients because it attached, it is remaining. And you can take any example. For example, in minus 9 x square z. So in this numerical coefficient is minus 9. That is numerical coefficient. And when you come to the literal coefficients, that is x square z. So except number, remaining everything is literal coefficient. And separately also you can find out coefficient for individual. That is, okay, see here example, x square y z is given. In this x square coefficient means except x square remaining, that is yz. So x square coefficient is equals to yz, and y coefficient is except y remaining is x square z, and z coefficient is x square y. Okay, in this and so on. So you can take coefficient of particular value if they asked. Apart from that, remaining also you can take. Now these are coefficients. And next you'll see like terms. Like terms example I'll explain you. So when you see about like terms, the terms having the same literal coefficients are called like terms. Same literal coefficient. Now coefficient I explained previous. Every term they should be have same literal coefficient. For example, in 7a square, 7 is the numerical coefficient and a square is the literal, right? And 8a square, so literal coefficient is a square. and minus 7a square. So literal coefficient is a square. So now these are all like terms. So it's simple to understand. The terms having same literal coefficients are called like terms. Otherwise they are called remaining, or we can call unlike terms. Now if you see 7xy comma 8xy comma minus 3xyz. So these are all unlike terms because literal coefficient is xy but xyz. So this is different, xyz. So this you can call unlike. So like terms means the terms having the same literal coefficient are called like terms, otherwise they're unlike terms. Now same literal coefficient, they're all like terms. Okay, 6a square, 7a square minus 8a square, these are also come under like terms. Okay, same value which is giving literal. So here this is a like terms and this is also like. So these only unlike terms down which is. So terms having the same literal coefficients are called like, otherwise they are called unlike terms. Okay, this way we can explain about this like terms and unlike terms. Any examples are given. So not only two, more than also you can take. If they'll give examples, we can say whether they like or unlike. Okay, 3x square comma 3y square. So this is unlike terms because the literal coefficients are different. And 3x minus 4x 7x. So because literal coefficient is x here, so that way these are like terms. So we can directly say when the examples are given whether they're like or unlike terms. Now using this concept, how to do the polynomials. So after here the algebraic expressions in this, again we'll see next polynomials and degree of the polynomials and what is the types of polynomials also I'll explain you now. Polynomials. Okay, before going this, I'll explain you difference between multinomial and polynomial also. Now when we compare this both, so generally polynomials is an algebraic expression in which variables involved have only non-negative integral powers. It's called polynomial. So for example, you see one example for multinomial also. Then understand clearly what is the difference between these both. Multinomial. If you see example, every polynomial is multinomial, but every multinomial need not be polynomial. Now multinomial means combination. Okay, more than one term. The algebraic expression containing more than one term is called multinomial. Now 2x square plus 3 by x, 4x to the power minus 3. So these are all multinomial. But when you come to polynomial, there should be only non-negative integral powers. Here power is minus 3 and 3 by x. This x if you take up is x to the power minus 1. So there in negative powers is coming. So only positive power is a polynomial. So when you come to the polynomials, an algebraic expression which the variables involved, so which is the variables involved, have only non-negative integral powers. That's called polynomial. Now 2x square plus 3x plus 4x to the power 3. So only positive powers. If there is no power means is 1. Right? Only non-negative integral powers. If it is having, there is a polynomial. Now 2x to the power 2x square plus 3x by y square. So I should not write like this because this y square. Now this value if you also is a multinomial but not polynomial, because y to the power 2 if you take numerator place it becomes y to the power minus 2. So this is a not polynomial. Have only non-negative integral powers. Okay, there is a polynomial. At multinomial is need not any restrictions. Is only algebraic expression containing more than one term. So only combination of the terms only multinomial, but polynomial means along with the combination of terms, the term should be have only non-negative integral powers. Okay, so now when you come to the, so we'll see now degree of polynomial also. Now don't say about multinomial. Now this topic will continue about only polynomials. So after getting the concept of this polynomial definition, now we'll see degree. degree of polynomial. So it's more than one term. All polynomials, but they should be have only non-negative integral powers, which I explained. So highest power, the degree means highest power of the variables in the polynomial of one variable is called degree of the polynomial. So highest power. If I say example, understand. For example, I am taking one question. Okay, polynomial 7a cube minus a square minus 5a plus 3. So this is combination of four terms. So your highest power of the variable in polynomial of one variable. So a power 3, a square and a power 1. A is a variable but highest power is 3 for this. So degree is equals to 3. Only highest power of a one variable you should take. Okay, let me show you some more examples. First of all, we should find out whether it's a polynomial or not. Then only we are able to say the degree. Okay, 6 plus 5y square minus 7y to the power 4. So it's a polynomial because all the powers are positive. And degree. So degree of this is here y square and y power 4. So 4 is highest. So degree of a polynomial, degree of this polynomial is 4. Now let's see one more example. So I'll give you example, you check whether it's a polynomial or not. If I take 3x plus 3 by x is an expression but not a polynomial. Okay. So because it contains a term namely 3 by x. This 3 by x I can write 3 into x to the power minus 1. So power is a negative integral minus 1. That's what it's not a polynomial. So which is not a polynomial, you cannot find the degree for that. Which is the power is minus 1 is come. So which is not a non-negative integer. Therefore it's not a polynomial, so there is no degree for that. So any examples are given, first you need to find out whether it's a polynomial or not. If it's polynomial, highest power of any one term, means any one variable. For all variables, which is the highest power, that only you can take. Now, so based on this number of terms and according to the degree, so according to the degree, we have some types. Okay, highest power it is only 1, what the polynomial it is. Highest power is 2. So in first example, highest power is 3. So degree is 3 and the degree is 4. Okay, according to the degree, then we can say some type of polynomials. I'll show you here. First one, linear polynomial. Linear polynomial. So linear means a polynomial of degree 1. Okay, if degree of any example, if it is 1, then that is called a linear polynomial. A polynomial of degree 1 is called linear polynomial. Okay, example 3 plus 5x. So x to the power 1. Okay, 6y minus 5. 3 by 2 plus x. So these are all examples. So highest power means degree of this polynomial is only 1. Because x to the power 1 by power 1. There is no power, you can take it as 1. So only 1 is the degree. Next, quadratic polynomial. You see here. So highest power is only 1. There are all polynomials you can call linear. Then degree, a polynomial of degree 2, that is called quadratic. Okay, quadratic polynomial means degree should be 2. So degree is nothing but highest power of the polynomial. There should be 2. So if the polynomial having the degrees 2 is called quadratic polynomial. So when you see examples for this, similarly 8x square minus 7x plus 2. So such type of examples is called quadratic polynomials. So highest power degree is 2 for this. Okay, and 2 minus 2y plus 6x square 3y square. So same variable take. Variable must be same. Are the both quadratic polynomials. Next, cubic polynomial. Cubic polynomial. So the word term says cube, big. There is a degree is 3. A polynomial of degree 3 is called cubic polynomial. That means highest power is 3. So that we can write an example for that. So 3x cube minus 6x square plus 2x minus 5. So this is example. Otherwise only 6x cube plus 2. This also cubic polynomial. Don't see the number of terms. So degree only must be 3. Then it's a cubic polynomial. And last one is a constant polynomial. So what it says. So you know about the constant, right? So constant polynomial. It's very simple. A polynomial having one term consisting of constant only is called constant polynomial. Degree of the constant polynomial is 0. That means there is no literals, no variables. That is degree is 0. Okay, polynomial having only one term consisting of constant. Okay, take example 7 by 2 is a constant polynomial because only one term and there is no literals. Any number you can take, minus 151, any fractions or both, these are constant polynomials. And you can take minus 3, minus 6 by 7, such type. Any example you can take, any number. These are all constant polynomial. Means a polynomial having one term consisting of constant only, which is called constant polynomial. And degree of the constant polynomial is 0. That's why you can call constant polynomial. So these are the type of polynomials: linear, quadratic, cubic, and constant. And degree of polynomial in 2 or more variables. So these are all only single variable, right? X, only x variables here, only y. Variables is same in throughout examples. So how to find out the degree of the polynomial in 2 or more variables also, I'll explain now. So degree of polynomial in 2 or more variables. If any polynomial which is having 2 or more variables, then how to find out the degree for that? Okay, let me write the statement, the condition, how we need to find out. For example, if a polynomial involves 2 or more variables, so involves 2 or more variables, then the sum of the powers of all the variables in each term is taken up, and the highest sum so obtained is the degree of the polynomial. So this is the condition. I'll explain now. Okay, if you observe degree of the polynomial in 2 or more variables. Let me take one example first. Okay, for example 6x cube minus 2x square y. So variables are 2 or more, plus x square y square minus 3x square y square. Now if you come to this polynomial, there are 4 terms. 1 2 3 4 4 terms are there. Polynomial involves 2 or more variables, then sum of the powers of all variables in each term. Each term you need to find out the sum of all the variables. In first term, x cube only 3. In second term, x square 1, x square and y power 1. That means overall 3 because 2 plus 1. In fourth term, sum of the powers of all the variables is 4 because x square and y square, 2 plus 2. You need to add this both. When you come to this x square, y square, so 4. So highest, after taking up the highest sum, so obtained is the degree of the polynomial. So highest is 4 overall. Both 4s came. So here degree is equals to 4. So only thing is we need to add all the powers of all the variables in each term. Then from that we need to find out which is the highest. There's a degree. Now let's see one more example. We need to check whether the polynomial or also not first. Then 2x square y cube minus 3x y square plus 5x cube y cube. Only 3 terms are there. Now if you see the degree, x square y cube, so it is 5 total. X y square, x power 1 it is, so 3. X cube y cube is total 6. So the degree is equal to 6. After adding the powers, then highest one we can take it as the degree. And let me explain one more example. You can verify if it's a polynomial or not also. First of all, 3ab square minus 4a root b plus 5b cube. So in this expression, when you come to, there are 3 terms. First term a power 1, b power 2, so totals is 3. The third term is b cube, so 3. But when you come to here, it's a power 1. So a power 1 and b power root b means you can write b to the power 1 by 2. Square root is power 1 by 2. So 1 plus 1 by 2. That is 3 by 2. So it's a fraction now. That's with anything you are coming. So it should not be already explained non-negative integral powers. So expression, but it's not a polynomial as it contains the term which sum is 3 by 2 is coming. So which is not a non-negative integer. So this is not non-negative. So this is not a polynomial. So when it's not polynomial, you can't find the degree for that. So anything. One more example also is not. I'll show you one example here. 4xy minus 3xy square plus 3x by y. It's containing 2 or more variables. 2 variables separately. But when you come to this polynomial or not, it's not, because 3x by y, we can write it as 3x y to the power minus 1. So it's a not non-negative. It's negative integers only is getting. So it's not a polynomial. So whenever it is the polynomial for 2 or more, we need to add the powers for each and every term. In that highest one only, we can take it as the degree for that individual polynomial. Okay. Next, when you see one method, substitution. So whenever the polynomial is given, the values are given, how to substitute and solve. So let me show you a simple example. Now find the value. Okay, write me question. Find the value. This is substitution. Find the value of m cube plus n cube minus p cube minus 3mnp. So here 3 variables. So it is a polynomial, right? So highest power is 3. So degree is 3. So find the value of this. But when condition is when m is equals to 4 and n is equals to minus 3 and p is equals to 2. So whenever these values are given, find the value for this. So we need to substitute m is equal to 4, n is equal to minus 3 and p is equal to 2 in the given expression. Then we can get the value of this. That is m cube plus n cube minus p cube minus 3mnp. Now when you substitute, m value is 4. So in the place of variable, that number we need to substitute. M is equal to 4. So 4 cube plus n value is minus 3. So negative value is coming, keep the bracket, minus p is equals to 2 cube minus 3 into 3m and p. So in algebra, we need to multiply everything, all the variables. When writing no into symbol, no dot symbol also is multiplication. Okay, n is minus 3 and p is 2. So we need to simplify this to get the value. Okay, it's a 4 cube is 64 plus minus 3 cube is minus 27 minus 2 cube is 8, and here minus into minus is plus, and 3 4s are 12 and 12 3s are 36, 2s are 72. Finally, now simplify 64 minus 27 minus 8 plus 72. Add the positive values, 136, 64, 72. 64 is positive, 72 is positive. Add the positive numbers, 136. Keep minus sign and add the negative numbers, 27, 38, 35. That is 101. So this is the value. So any term is given, just you need to substitute the values. And if they're asking to find the value, you just substitute the values in the place of variables, and need to simplify to get that one. And how to do addition, subtractions of multiplication, divisions in polynomials also, I'll explain you one by one. So now we'll see how to do addition of like terms. So already I explained about like terms. So like terms is nothing but the terms which is having variable is same. Okay, whenever the variables are same, they are called like terms. Now how to do addition of this? So it's very simple. The sum of two or more like terms is a like term whose numerical coefficient is the sum of the numerical coefficients of the given terms. This is the definition. So I give example clearly. First let me take like terms, then how to do addition. So for example, same variable. So 6xy square is one term, and minus 2xy square minus 5 by 6 xy square and 2 by 3 xy square. So all variables are xy square only. That's why this 1, 2, 3, 4. These 4 are like terms. Now add these 4. So add these 4 terms. So according to the method, we need to add only the coefficients. Coefficients of this 4 terms is nothing but sum of these 4 like terms. So that's why we can do required sum. We need to add this 4. That is 6 xy square plus, and second is minus 2xy square plus minus 5 by 6 xy square plus 2 by 3 xy square. Whenever you get negative sign, just keep the bracket. So understand clearly and should not get confused. Then what we need to do, we need to take all the coefficients we should add first. Then xy square is common for all 4 terms. Then coefficients are 6 minus 2 minus 5 by 6 plus 2 by 3. These 4 are the coefficients. Okay, 6 minus 2 and minus 5 by 6 and 2 by 3. These 4 we need to add. Now we'll get directly answer here. 6 minus 2 is 4. Okay, minus 5 by 6 plus 2 by 3 xy square. So if 4 means 4 by 1. Just do LCM and solve this. 6 is LCM for 163. That I am taking 1 in 6 times 6 4s are 24 minus 5 plus, simplifying directly, 4 xy square. 24 plus 4, 28 minus 5 23 by 6 xy square. So this only the sum means addition of like terms. It's very simple. Only coefficients we need to add to get the final answer, and variables are same. That's why you can call like terms. So they are the common for them. Now similarly we can do subtraction of like terms also. So see here, subtraction of like terms. Same how we did addition, we did same we need to do subtraction for these terms. Only for like terms we'll see first now. So that means the variables are same. Now for example, take subtract. Addition you can take any number of terms, but subtraction should take only two terms. Subtract at a time. So subtract 6a square b, okay, from 9a square b. You need to subtract 6a square b from 9a square b. So these both are like terms. Then we can write from 9a square b. That's what 9a square b minus what you have to subtract 6a square b. So a square b is the common. That's a like term, common variable. Then coefficients you need to subtract 9 minus 6. Then 9 minus 6 is 3. So 3a square b is the result for subtraction of this. So it's very simple subtraction. Then subtract alternate method also you can take for this. For example, means vertically we can write and we can solve. So it's alternate, changing the sign. Now question is like this: subtract minus 3ab from 7ab. So this alternate method is what you need to subtract, from which you have to subtract, that we can write on top 7ab, and what you have to subtract minus 3ab. So whenever you subtraction, the down term sign should be changed. Now this minus should become plus. Okay, when you are subtracting. Now don't see this minus 3ab, now it's plus 3ab. Now 7ab plus 3ab is 10ab. So required difference is 10ab only. This is a vertical we can write. We can use in addition of subtraction of polynomials also, the same concept. Okay, in this way you can do subtract. Only thing is when the like terms are there, that term variables you can take common, and only we will do the addition or subtraction only for the coefficients. And next we will see how to do addition and subtraction of polynomials also. So this is addition of subtraction of like terms. Next I'll explain you addition and subtraction followed by multiplication divisions of polynomials also we'll see now. So how to do adding of polynomials? So I need to do addition of these polynomials. So whenever two or more polynomials can be added by arranging them so that the like terms lie on the same vertical column. First we need to arrange the same vertical column, then adding each column beginning from the left. Okay, I'll give you with example first. So any polynomials are given, how we need to add them and how to arrange properly. So add, so this is the question, add 4b minus 7c plus 10, comma 5c minus 3b minus 28, and 15 plus 11c plus b. Okay, three polynomials are given here: 4b minus 7c plus 10, and 5c minus 3b minus 28, 15 plus 11c plus b. So we need to add this first by making proper order, arranging in order. So for first question I am taking as this, the first polynomial 4b minus 7c plus 10. So first term is b variable and second term is c, variable is c, and third term is constant. Now second polynomial also you need to arrange in the same order. Now 5c, first is 5c, right, plus 5c. Under c term we need to write the c variable term. minus 3b under b variable minus 28. Okay, this must be in order. So arranging column wise with like terms in the same column and adding, we'll get the answer. And next 15 plus 11c. So here 15 means positive 15, 11c plus 11c plus b. So b is here. Okay, first two three added in vertical. Now we need to do addition of this directly. So adding is very simple. Because of the like terms, we'll add only coefficients. So here my plus 4 minus 3 and 1. There is nothing means 1. Okay, 4 minus 3 is 1, 1 plus 1 is 2. So finally 2b it is. And variable we write as it is. Now minus 7 plus 5. That is minus 2. Minus 2 plus 11 is plus 9. 9c. And 10 plus 10 plus 15. 25. 25 minus 28 is minus 3. Okay. Just we'll add only the coefficients. If it is negative, we'll subtract. Positive means we'll add. Okay, in this way we can do addition. And I'll explain one more example for clear understanding. We'll take more variables terms. Okay, let's see the question. Add x cube minus 6x square y plus 7xy square plus y cube. This is the one polynomial and we need to add to this 2x square y minus 7y cube. Second and third polynomial is given 6y cube minus 5x cube plus 4x square y minus 2xy square. Okay, these three we need to arrange in like term wise, then we need to add. Any term is like term is not there means we can give the gap as it is. Okay, let's see the solution. X cube minus 6x square y, this is the first polynomial, plus 7x y square plus y cube. Now under this next is 2x square y. Okay, if you observe next term, next polynomial only two terms, x square y and y cube. So under x square y we'll write this first term and minus 7y cube. Under y cube we'll write this 7 and first and third will give the gap as it is. 2x square y minus 7y cube. This was second. Now third polynomial is 6y cube. Here 6y cube minus 5x cube. First term place. Next to x square y. The second term place. 4x square y and minus 2xy square. Now this is plus value. These three terms. So column wise we need to do addition. Now it's simple. Now take only the coefficients. That is x cube coefficient is 1. There is no means 1. Okay. 1 minus 5. This is minus 4 x cube. So 1 minus 5 is minus 4 x cube. Next is minus 6 plus 2 is minus 4. Minus 6 plus 2 is minus 4. Minus 4 plus 4 is 0. So 0 into x square y means that is completely 0 will come. So need not write. Whenever they get the coefficient 0, so don't write as, just leave it, because 0 into something is 0. So need not to take this. Okay, once you got the coefficient sum is 0, so neglect the variable. Now plus 7 minus 2 plus 5. xy square, and your coefficient is 1. 1 minus 7 is minus 6, minus 6 plus 6 is 0. You also 0 you're getting, so leave this. Now finally answer is so required sum is equals to minus 4x cube plus 5x y square. That's it. So this is the way we can do addition. And one more sum I'll show you, which is simply difference. Only two terms, and no perfectly common in all, then how to solve. So let's see the question. Add a cube minus 1 polynomial and 2b cube minus 3b 4c cube minus 5c square. So this polynomial I need to add. So if you do in vertical way, so you can write in order. First one is a cube minus 1. There are two terms. So next to 2b cube, that means there is no any b cube term. So separately you can write, give gap, plus 2b cube minus 3b, because b term also is not there in first. Next to 4c cube. Okay, c cube is not there. That's why you can give gap and write 4c cube minus 5c square. So there is no any common like terms in all the polynomials. So write separately and just write as it is down. Therefore solution is a cube minus 1 plus 2b cube minus 3b, because there is no like terms, right? So I am writing as it is, 4c cube minus 5c square. That's it. So this only the required answer itself. So required sum is a cube minus 1 plus 2b cube minus 3b plus 4c cube minus 5c square. So if there is no any common like terms, then we can write the values as it is also. Fine. So this is the way you can do addition. Whenever the polynomials are given, we can make them in order and we can make it. And I'll explain you subtraction also. So when the polynomials are given, some are like terms, some are non-like terms, how to do subtractions also I'll explain you now. So let's see subtraction of polynomials now. So two polynomials are given, how to subtract. So generally you need to subtract only two polynomials are required. So rearrange the terms of the given polynomial with like terms first of all, and write in some vertical order. Then change the sign of each term of the polynomial to be subtracted. Then add the two polynomials. Okay, I'll explain with examples brief and clearly. So a question is subtract So I'm taking two polynomials. So one is a cube plus 3a square b minus 5a b square minus 2b cube. So I need to subtract this from b cube minus a cube minus 3ab square minus 2a square b. So these two polynomials, first polynomial subtract from this second. So according to the condition, first we need to write in order, arrange the column wise with like terms in the same column. Okay, then we'll get first subtract from. So from what you are subtract, that should be right first. Okay, this from this I need to subtract, that is b cube minus a cube minus 3ab square minus 2a square b, right? This is you should write first place, followed by this second one. So write in order. So when you write the second polynomial, first of all b cube minus a cube minus 3a b square minus 2a square b. then followed by second place the first polynomial, because that we have to subtract from this. Next, write in order. Order means first b cube term. B cube term is minus 2b cube. Minus 2b cube. Next a cube term is plus a cube is there. Order. Next ab square. Ab square is this. Okay, ab square is different and a square b is different. Okay, minus 5ab square and plus 3a square b. So this is the first step. Arrange the column wise with like terms. Now changing the sign of each term in the second place. So it's very important. We need to change the sign of the second place because we are going to subtract it. That means you change the place. If it is minus 2b cube, it becomes plus 2b cube. This is plus becomes minus. Just only change the sign. Minus to plus, plus to minus. Okay. Now don't consider this is minus 2b cube first one. After changing, so it's not minus 2b cube. Now it's a plus 2b cube. So first term and second term we just to do addition. So we have plus b cube plus 2b cube. It's total 3b cube. So it's a 1b cube plus 2b cube is 3b cube. So after changing sign, add the first and new polynomial. Just only add the first and new polynomial. Next to minus 1 and minus 1 also here. There's no number means it's a 1. Okay, minus 2 a cube. Then minus 3 plus 5. Say about this is minus 3 and it's plus 5. So plus 2. So don't see the old one sign. New sign and first polynomial only you should add the coefficients. Only addition. After changing sign you should add a b square and minus 2 minus 3. It's a minus 5 a square b. Okay. Now this is only required polynomial. So 3b cube minus 2a cube plus 2ab square minus 5a square b. When you do subtract, only changing here first you should change the sign for down second polynomial. After arranging, then you should do addition. First coefficient and second coefficient only we need to add. This is the way. So okay, one more example I'll explain you. Now question is subtract 1 minus x minus x square plus x cube. This I have to subtract from, that is 2x cube minus 3x square plus 4x minus 13. Okay, from what you have to subtract, that should be right first. Now solution is 2x cube minus 3x square plus 4x minus 13, because from this you have to subtract, and what I have to subtract, that should be down in order. Again x cube term is first, 1 minus, so x cube term is a positive x cube term is there, this one, and minus x square is term also is there, and minus x plus 1. So if you can make in order, this is 1. After changing order, what I said, you need to change the sign. Okay, you need to change the sign. So plus x cube becomes minus, and this is a plus, it is also become plus and minus. Now don't see this previous, then you should do normal addition, first coefficient and second coefficient. So 2 minus 1 it is, so there is only 1, that means x cube. So don't get confused, the number if coefficient is not there, it's a 1. So 2 minus 1 is 1, so I am going to keep here 1 always. Then minus 3 plus 1, so minus 2x square, and 4x plus x, so 5x. Minus 13 minus 1 is minus 14. Okay, minus 13 and minus 1, because you should not see the previous sign. So this way we can do subtraction of the polynomials. The only condition is we need to arrange them in column wise with the like terms in the same column. Then just to do adding the first and the new polynomial. There's only you'll get the answer. Okay. This way you can do subtraction of two polynomials in our given. And similarly, how to do multiplications and divisions. That isn't different. So I'll explain you how to do multiplication of monomial and multiplication of polynomial by monomial, and next followed by divisions also I'll explain now. So in multiplication of polynomials, the first one is multiplication of monomials. So you must know this is one of the important. And product of law of exponents. When you see the formula is a to the power m into a to the power n. So bases are same and we can add the powers. A to the power m plus n. So this formula and this concept will use in this multiplication of monomials. So let me explain. So monomial means the term which is having only one. So one term is nothing monomial. How to multiply? So if you take two terms, one is 6a square and another term is minus 3a cube. So I need to add this both. I need to multiply this both monomials. So there are three important rules. First we need to multiply sign. So whenever you need to multiply the monomials, just remember these three rules. So sign you should multiply, then numerical, then variable. First, when you want to multiply sign, you should know the four formulas. That is a plus into plus is equals to plus only, positive, and plus into minus is minus, and minus into plus also is minus, again minus into minus is equals to plus. Okay, these you remember to multiply the sign. Now multiplication of monomials. Now when you see this problem, 6a square and multiply with minus 3a cube. Okay, 6a square into minus 3a cube. So first step is you need to multiply the sign. So when you come to the sign, plus into plus is plus, plus into minus is minus. But here first is this term is positive. If there is no sign, it's a positive term. And next is negative. So plus into minus, minus. So second one, plus into minus is minus. So sign is negative now. Overall solution sign is negative. Now next to numerical. So after sign is finished, then numerical. Number, this constant. So here number is 6 and it is 3. Because sign is over, sign part is over. Now 6 into 3. We need to multiply. Into next is variable. So a square and a cube. So this formula apply. A power m into a power n is equal to a power m plus 1. So a to the power 2 plus 3. Powers you need to add. Now simplify everything. Minus 6 3 is 18. A to the power 5. Okay, minus 18 a power 5 is the product of 6a square and minus 3a cube. So this way I can multiply. I'll show you one more example also. So I am taking two terms, minus 6 a square b should be multiplied by, multiply first one by 1 by 2 ab square. So whenever I need to multiply, keep the multiplication symbol. Now that is minus 6 a square b is the first term into 1 by 2 ab square is the second term. So before multiplying, just apply these three concepts. First sign we should multiply. Okay, when you are taking sign, first one is negative, second is positive. If there is no symbol, just take it as positive. And minus into plus is minus. Overall sign is negative. Now next numerical. So first term constant is 6, second term constant is 1 by 2 into next variable. Here a square b, a b square. Overall a how many times? Here a square and a power 1. So finally a power 3 it is. And b, here b power 1 and here b square. So overall it's a b3. A cube, b cube. Now you can simplify this. 2 ones are 2 3s. So you can cancel. Then minus 3 a cube, b cube. So need not to keep the into symbol in between. So minus 3 a cube, b cube. So this way we can multiply thing. Now let's see one more example. So multiply. So important three concepts, three rules you remember when I was asking about multiplication. So multiply minus 3 by 4 x square y cube by minus 8 by 9 xy square. Okay, so according to our method, just to multiply this both, minus 3 by 4 x square y cube, this one first term multiplied by minus 8 by 9 xy square. Okay, first is sign, you see it, minus and minus, first term is negative, second term also negative, then minus into minus is plus. So plus symbol need not to keep starting. And next to variable. Okay, plus symbol, minus to minus is plus because starting is minus, second term also negative, minus into minus is plus. So this four rules you apply: plus into plus plus, plus into minus minus, minus into plus minus, again minus into minus also is plus here, and both are negative positive, and both are positive also positive. If any one is negative, the negative will come. Okay, remembering that. So account that is a positive. Now next number means constant. First term constant is 3 by 4 and second term constant is 8 by 9 into next variables x square and here x power 1. Okay, when you observe x square and x power 1, nothing means 1. Now finally x cube and y power 3 and y power 2, so overall y to the power 5. So same formula, a to the power m into a to the power n is equals to a to the power m plus n. Okay, this formula remember to do multiplications of monomials. Now I can try to simplify if it is possible. 3 ones are 3 threes, I can cut. 4 ones are 4 twos are 8. Then finally plus need not to keep. So 2 by 3 x cube y power 5. That's it. So this way we can multiplication of monomials. So important concept is this. You remember this sign, numerical and variable. One by one if you multiply, you will not get confused, you will get exactly the answer. So not only multiplication of monomials, next I'll explain multiplication of polynomials by a monomial. This is multiplication of only monomials. So if it's more than one term, how to multiply with the single term. Also I'll explain now. So here I'll explain multiplication of polynomial by a monomial. So in this case we apply distributive laws. Okay, about the distributive laws already you know. A plus B into C. So A plus B, if you want to multiply with C, then we will distribute, that is A into C plus B into C. That C is a monomial and it is a polynomial. That means we will divide, we will distribute separately. Or else if in negative also same. If it is A minus B into C, then we can write it as A into C minus B into C. So if the term is starting, otherwise A into B plus C, this also you can distribute, that is left side is right side. Now this you can write A into B plus A into C. A value will distribute for both. Negative, if you take A into B minus C, also will distribute AB minus AC. Okay, this concept only will apply when you multiplication of polynomials with monomial. Okay, find the product. Now let's see the question 1. Find the product. Product means multiplication. Find the product two a cube plus 3a square b. This one I should multiply with minus 1 by 2 ab square. Okay, same I explained, which I explained in the monomial, multiplication of monomial with monomial. Same rule will apply, but first we need to distribute this for both. Now when you come to the solution, According to distributive law, 2a cube plus 3a square b. This is the polynomial. I am multiplying with monomial is minus 1 by 2 ab square. So in this polynomial there are two terms. These two terms we should distribute first. That what you can write 2a cube into minus 1 by 2 ab square. Again with second term of the first polynomial plus 3a square b into again minus 1 by 2 ab square. Okay, this is the distributing. Now next same rule which applied in monomial, multiplication of monomial, same we apply for separately for both. First you need to multiply the sign. So plus into minus is minus. Next to constants. So 2 and here is constant is 1 by 2. Okay, first is plus, this is no sign means plus, plus into minus is minus. And 2 into 1 by 2. Next to variable. A cube, here is a power 1. So a to the power 4 and b square because there is no another b letter. Plus. Now in this term also again there is no sign means plus. So plus into minus is minus. And 3 into 1 by 2 a square into a, there is a cube, and b square, here b power 1 into b square is b cube. Okay, now try to simplify this. Now if you simplify, 2 to get cancel, minus a power 4 and b square, and here plus into minus is minus. 3 into 1 by 2 is 3 by 2, a cube and b cube. That's it. So in this way you can simplify. So minus a power 4 b square minus 3 by 2 a cube b cube. So after using distributive, then we can just normally multiply. Not only two terms, if it is more than two terms also we'll do same. So let's see one more example. Multiply. So they can ask the question product or multiply, everything is same. 5a square b minus 3ab square plus 4ab minus 7. So I need to multiply this by one monomial is 3a square b. Okay, with 3a square b we need to multiply each and everything. Now here there are total 1, 2, 3, 4 terms. 4 term should multiply this monomial. Now split it separately. Then solution. That is first term is 5a square b. So that I am writing into 3a square b because we need to multiply with this. Minus. And second one is 3a b square into same 3a square b. Plus, because second term is plus, this is minus, minus into plus minus, that time multiplied sign also. Then 4ab also same 3a square b, again minus 7 into 3a square b. Okay, everything is multiplied. Then simplify each and every terms as the monomial rule. Now that multiplies number because sign already multiplied. 5 3 is 15, a square, so a power 4 and a b and b, 2b, so b square minus, and number second term 3 into 3 is 9, a square is a cube and b square b is b cube. Next plus 4 3 is 12, here 4 and 3, and a square is a cube and b square. Similarly minus 7 3 is 21 and a square b. Fine. So this is the final result. So 15 a power 4 b square minus 9a cube b cube plus 12a cube b square minus 21a square b. Okay, this way we can multiply any polynomial with monomial. We need to multiply, we need to split. So we need to use the distributive laws first. After distributing, then you can use normal multiplication rule of monomial. So this is multiplication of a polynomial by a monomial. Next I'll explain multiplication of two polynomials. Okay, two or more polynomials also. How to multiply, I'll explain. So we will see here multiplication of two polynomials. Whenever they given two polynomials, how to multiply them. Okay, multiply each term of multiplicand by each term of multiplier and take the algebraic sum of these products. Now let me take one example, you understand clearly. So multiply 3x minus 5 plus 2x square. So this is a polynomial. By, I need to multiply this polynomial by 5x plus 3. Now this is multiplicand and multiplier. So the condition is, first we need to arrange the multiplicand in descending order of powers of x. Then multiplying we get. So 3x minus 5 plus 2x square. If you make in descending order, so highest power to lowest power, means degree, highest degree to lowest degree, we need to convert first. Now 3x minus 5 plus 2x square. So these two polynomials I need to multiply. So I'm taking in order. If we write, that is 2x square, highest power is 2, total 3 terms. So highest power is 2, so 2x square. Next power is 3x to the power 1 minus 5 constant. So take this multiplicand, this is a multiplicand and this multiplier. So whenever you're multiplying two polynomials, one is we can call multiplicand and multiplier. So take multiplicand and write in descending order according to their power of x. X power 2, x power 1, x power 0. There is no nothing means. This I need to multiply by 5x plus 3. This also must be written in order. So 5x plus 3 it is. 5x plus 3. Okay. So I need to multiply this. So thing is, we need to multiply every term. Now take 5x and multiply above 3 terms first. So it's very simple. Take 5x, multiply 2x square. Again take 5x and multiply with 3x. Again with 5x, multiply with minus 5. And write in first row. So first of all, multiplying by 5x. Okay, direct time writing 5x into 2x square, because I already understood how to multiply polynomial, monomial with monomial. Now 5x is one term, 2x square is one term. We need to multiply in order. First sign, numerical value and variable. So 5x is positive, 2x square is positive, so plus sign need not to keep. Next to 5 2s are 10. X into x square is x cube. So with 5x, 2x square. Again with 5x, 3x. Plus into plus is plus, because 5x is positive, 3x is positive. 5 3s are 15. X into x, x square. Now take again 5x and multiply with minus 5. That is minus 25x. Okay, take this first term and multiply each and every term in the multiplicand. Now take 3. Next term is 3. Right. Now take this 3, again multiply each and every term in this. Each and every term. So 3 into 2x square. There is 6x square. Write in next place, because highest like terms only should write in order. 3 into 3x plus 9x. Okay, again 3 into minus 5 is minus 15. That's it. Take the each and every term of this multiplicand and multiply each and every term in the multiplicand also. Now just to do addition of this both. So when you do addition, that is 10x cube. Like terms additions, already learn addition of the polynomials, right? Plus 15 plus 6. Okay, it's 21x square 25 minus 25x plus 9x is minus 16x and minus 15. That's it. So this is the product. If there is any like terms, again we can simplify. So there is no like terms in this. So each and every term we need to multiply each and everything. Okay. I'll explain one more example. You understand better more clearly. So let me take one example. Multiply 3x to the power 4 minus 4x square plus 2x minus 5. So now this polynomial I need to multiply by, multiplier is here is 2 plus x minus x square. So there are three terms. So it's very simple, just you need to multiply 3 times. Now just note down the question. That is write in order. So 3x power 4 already is in order question itself, minus 4x square. So there is no x cube term. So write as this, plus 2x minus 5. Okay, this I need to multiply with, write in order, 2 plus x minus x square. If you write in order, that is minus x square plus x plus 2. Okay. Now first of all take minus x square and multiply each and every term on top. Now take this, I am writing the symbol, this color one, minus x square, multiply each and everything. So minus x square into 3x power 4. So that is minus 3x to the power 6. Okay. Now this one into second. There is no x power 5, so give little gap. Plus minus to minus plus x square into 4x square is 4x to the power 4. So there is no x power 5 term, so I am giving gap to do it clearly. Minus same and third one, minus x square into plus 2x is minus 2x cube. Again with this next, minus to minus plus 5x square. Okay. Similarly with x and plus 2 also, next other two terms also you can take same. Now take this x and multiply each and every term on top. So x into 3x power 4. So that is 3x power 5. It's a power 5 term. So plus it is positive value. Next x into minus 4x square is minus 4x cube. So under cube you can write. For like terms it's easy for calculations. And x into 2x is plus 2x square. And minus 5x. Minus 5 into x is minus 5x. That's it. Now take the third term. Okay, changing the color. 2 with the number 2 again multiply first, second, third, fourth. So with 2 into 3x power 4. That is plus 6. Plus 3 to the 6. X to the power 4. 6x to the power 4 because under 4 like terms I am writing. Next 2 into minus 4 is minus 8 x square. So minus 8 x square and plus 4x because 2 into 2x 4x minus 2 into minus 5 is minus 10. Now just need to simplify this. So according to like terms just continuously can order. So as descending order. Now x power 6 is only one term. So minus 3 x power 6. X to the power 5 also only one term. 3x to the power 5. Plus 4 plus 6 is 10 x to the power 4. So both. Again minus 6x cube. There are two terms. Again 5 plus 2 is 7. 7 minus 8 is minus 1. That's why minus x square. Minus x because minus 5 plus 4 and minus 10. That's it. So this is the product of these two polynomials which I was giving. So this way each and everything. So first multiply by minus x square, then followed by plus x and multiply by 2. Then normally addition like polynomial addition only under like terms only need to write. Then we can do add one by one simple. Fine. So this is the way we can do any multiplications. Any number of terms are given also same process. We can take in order and directly multiply each and every term. You need to remember the process. First you need to multiply sign, then number, followed by variable. So you can solve in this way. So this is the multiplications. Next I'll explain divisions. So it's the most important in polynomial. So how to do divisions of polynomials by monomial and polynomial divided by polynomial. So each and everything I'll explain now. So division of monomial by a monomial. So whenever you are taken two monomials, means only single term. A polynomial which is having only single term is called monomial. So how to do division of any monomial divided by again another monomial. So we need to use a law, quotient law of exponents. Okay, that is a to the power m divided by a to the power n. So whenever base is equal, then we should subtract the powers. A to the power m minus n. So when it's numerator and denominator, the both the powers, base is same. A is the base and m and n are the powers. So a power m by a power n is equals to a to the power m minus n. So this law of exponent we'll use in this division process in the division of polynomials. Okay, let me take one question first and I'll explain it clearly. For example, divide 24 a square b c cube. We should divide by minus 6 a b c square. So this is the first term and divide by second term. So we need to divide this. So this formula only will apply here. So before that we will write in order. This numerator divided by denominator. So when you come to solution, so it's very simple divisions. 24 a square b c cube. So three variables are here with different power. B only 1 means it's only 1. Power is 1. If the number is letter is L1. Divide by minus 6 a b c square. Okay, b to the power 1 and c to the power 1 it is. We can take like. Now first of all we need to separate the sign and number. So here also we have same rules as we applied in multiplications. Plus divided by plus is a positive one. So the same rules. So you already know the rules. That is plus divided by plus. Again we'll get positive number. If it is plus divided by minus, minus. And minus divided by plus is a minus. And minus divided by minus also is a plus. Same multiplication rules only will apply even for divisions. So overall, now here 24 is positive, 6 is negative. So plus divided by minus is minus. Finally negative it is. And 24 by 6. This number separately. Now when you come to the letters, that is a power 2. So once you are familiar, you can do cancellations later. B power 1, C power 3. By, so if there is no means power, you can keep it as 1. Then A power 1, B power 1 and C power 2. When you do calculation here, 6 1s are 6 4s are. So minus 4 up to numerical value. Now variables is a power 2 by a power 1. So see the formula here. A power m by a power n is equal to a power m minus n. So powers you should subtract. Means numerator power minus denominator power. So we can write here a to the power 2 minus 1 because a is on top and same a base as down. Similarly into b to the power 1 minus 1 into c to the power 3 minus 2. Okay. Now simplify this. A to the power 2 minus 1 is a to the power 1 and b to the power 1 minus 1 is 0 and c to the power 3 minus 2 is 1. Now we can write in simplest form. Any number to the power 0 is 1. Okay, a to the power 0 is equals to 1. Formula, any number. So b to the power 0 also 1. Any number to the power 0 value is 1. So minus 4, a power 1 means a, this is 1, c power 1 is c. So finally we can write minus 4ac. Okay, minus 4ac is a solution for this. Any divisions are given. Okay, let me explain you one more example of this division. Now divide minus 56 x y z cube divide by minus 6 x cube y to the power 4 and z. So try to solve this division. Now see the problem. So minus 56 x y z cube divided by minus 6 x cube y to the power 4 and z. So using the formula same, a to the power m by a to the power n is equal to a to the power m minus n. In case if its denominator power is more, then you can write in denominator place. Now see here, minus divided by minus is plus, answer solution is plus. You can go for cancellations if it is possible. 2 3s are 6 and 2 2s are 4, 8 is 16 carry. So 28 by 3, that is numerical part. Now z to the power, now x by x cube. See here, x power 1 on numerator but x power 3 on denominator. So numerator only you can take to denominator. So x to the power 3 minus 1. When you take to numerator to denominator, you have to change the sign. And y to the power 4 minus 1, because 1 only you are taking down. Z cube, numerator only z power 3 minus your denominator is z power 1. So minus 1. So you try to simplify. Whenever numerator power is more, then take denominator power only to the numerator place. Otherwise vice versa. Now so this is 28 by 3 z square by x square and y power 3. So finally we can write numerator part is 28 z square by 3x square y cube. So we can stop in this way. So this is the way we can simplify any values given and only taking the value. So using this formula, plus divide by plus. So and separately we can do numerical part and variables part separately. And this concept only will apply even when you are doing divisions, polynomial by a monomial. Also I'll explain it now. So here you'll see division of polynomial by a monomial. So for dividing a polynomial by a monomial, we divide each and every term of monomial of this polynomial by monomial. Each and every term we should divide. Same like previous class I explained monomial divided by monomial, right? Same concept, each and every term in this polynomial will divide with this given monomial. So single term. So let me give one question first. So divide. See how to divide. So question is 4x power 5 minus 14x to the power 4 plus 6x cube minus 2x square. So this polynomial I need to divide by 2x square, a single term. So each and every term you should divide with 2x square. So same formula, that is a to the power m by a to the power n, and bases are same, we'll subtract the powers, minus n, a to the power m minus n. So this law of exponent only we'll use. So let us solve this now. So when you come to solving this, each and every term, that is the given question is 4x to the power 5 minus 14x to the power 4 plus 6x cube minus 2x square. So this I need to divide 2x square. So including constant, we need to divide each and everything. So we can write the statement like this. 4x to the power 5 by 2x square. Again minus 14x to the power 4 divided by, because this 2x square is a positive, 2x square plus 6x cube by 2x square minus again 2x square by, so 2x square, last is same. So this value we need to simplify. Now when you can go for cancellations numbers if you're able to cancel it. So 2 table, 2 ones are 2 2's I can cancel here. Now balance is 2 and x to the power 5 by x square. So x to the power 5 minus 2. So formula I am applying, a power m by a power n is equals to a power m minus n, same formula. Now minus, if you cancel here 2 ones are 2 sevens are and 7 x to the power, so 4 minus 2 plus here 2 ones are 2 threes are, I can cancel 3 into x to the power 3 minus 2, so powers are subtracted, minus 2 to cancel, powers are same here, so x to the power 2 minus 2. Now try to simplify this final step. So we'll get, when you're simplifying, 2 into x to the power 3 minus 7 into x to the power 2 plus 3 into x to the power 1, because 3 minus 2 is 1, minus x to the power 2 minus 2 is 0. Now final step, if you simplify, that's only answer, 2x cube minus 7x square plus 3x minus 1 it is, because any number to the power 0 the value is 1. That's it. So each and every term we need to divide by this monomial, then only we'll get the solution directly. So not only this, any sum also same. Okay, one more question I'll explain you the same type of problem. So now divide 20x cube by, so it's two variables, 20x cube y plus 10xy square minus 15x square y minus 15x square y. So I need to divide by 5xy. Okay, let's see this one total divided by this. Now each and every term we should divide by 5xy. When you come to the solution, okay, see here, 20x cube y divided by 5xy, so positive both, plus 10xy square divided by 5xy minus again 15x square y by and 5xy. So each and every term. Now cancel it if it is possible. Any cancellations are there, you can cancel here. 5 table, 5 ones are 5 fours, you can cut it, right? 4 and y cancel also, same power also you can cancel, need not to again expand more. Then x power 3 minus 1, because x to the power 1 it is, there is no power. Okay, plus and 5 ones are 5 twos are 10, 5 cancel, x also you can remove. Then 2 y to the power 2 minus 1, because here y to the power 1, so formula minus 5 ones are 5 threes are, and here y is power 1, y power 1 is same, cancel. Then x to the power 2 minus 1, because top is 2 and down is 1 power. That's it. Now if you simplify, you'll get the answer, 4x square, because 3 minus 1, plus 2y to the power 1 minus x to the power 2 minus 1 is 1. So need not write the powers as 1. Now just simplify, that's only answer. Therefore the answer is 4x square plus 2y minus x. That's it. So this is the way we can do division any polynomial. So any number of terms divide by any single term. Okay, we can do the division like this. Now this is only dividing with monomial. In case polynomial, the special one is division of a polynomial divided by again another polynomial. So this is the most important type of problem. So division of polynomial by any other polynomial which is given. So how to solve, I'll explain now. Division of a polynomial by a polynomial. So it's the most important topic in this algebraic expressions, and we need to think over this. So how to solve also is important. So let me write the question directly first. So divide. So when I'm solving the sum, I'll explain you the method. So divide. So let me take one small simple question first. X plus 6x square minus 15. So I need to divide this polynomial by 2x minus 3 with this. So it's more than one term. So it's a monomial, already we explained previous now. Now this is a division of polynomial by another polynomial. So polynomial means the number of terms should be more than 1 and power is a positive. Now let us solve this. First arrange the terms of the dividend and divisor in descending order of the power of x. Whatever the power, you should write in descending order. Now divisor and dividend. So let me take solution clearly. Now 6x square minus x minus 15. So this one I need to divide by 2x minus 3. Okay. Now let us solve this step by step. Let me explain. So in both divisor and dividend, so in this dividend and divisor, first term we need to verify. So first term is here 2x and here 6x square. So these two terms 2x into dash is equals to 6x square we will get. So 2x, let's see, any problem is given, first check it roughly. 2x into dash is equals to 6x square. So first term in the dividend and first term in the divisor. So this is the dividend middle and this divisor. Then we will get the quotient and remainder. So 2x into dash is equal to 6x square. So first number you verify. Sign if you means plus, this also plus. So plus only will come. Here must be 3 because 2 3 is 6. And only one x is there, one more x we need. So 2x into 3x is 6x square, right? So take this 3x and write in this place of quotient. There's the first step. Okay, take the 2x first term in both. Now how many times if you multiply, that first will come, that is 3x you kept here. Now take this 3x and multiply this total divisor. Take 3x into multiply 2x minus 3. Now 3x into 2x is 6x square because same will come. Now take this 3x and multiply this total divisor. Okay, 3x into minus 3 is minus 9x. So after keeping the value, then take this 3x. Okay, so this is a 3x you got from this step, right? So take this 3x and multiply each and every term in this divisor and write here down. This is the first step. Do subtraction, like divisions I will do subtract. Subtraction means you should change the sign. So plus 6 becomes minus, minus 9x becomes plus 9x. Now do addition. So always first terms will get cancelled because same thing we got, plus 6x square minus 6x square and minus x plus 9x minus x here. Okay, so this the question is x plus, right? It's positive. 6x square plus x minus 15. Okay, so plus x plus 9x is 10x. And next term, the next term we should take to down, that is minus 15. So till here one complete session is over. Now again process is same. Again 2x. Okay, again first term in the divisor is 2x. Now dividend is this 10x. Now 2x into dash is equal to this 10x will come. So that you verify. Same now. Now again 2x into dash is equals to 10x. First term in the middle place. So 2 5 is a 10. So 2x into 5 is 10x. Now take this 5 and write here. Plus 5 it is. So keep plus 5. Now same method. Take this only plus 5 and multiply each and every term in this. Okay, now 5 into 2 x 10x here. Again 5 into minus 3 minus 15 is here. Okay. Now 5 into 2x, that is 10x. Again 5 into minus 3 is minus 15. Now take this plus 5 and multiply these both again, 2x and minus 3. Write down. Now change the sign. Minus 10 plus 10x becomes minus 10x. This is plus 15. Plus 10 minus 10 cancel. Minus 15 plus 10 cancel. 0. So remainder 0. Okay, when you do division of x plus 6x square minus 15 divided by 2x minus 3, we'll get quotient is 3x plus 5. So therefore x plus 6x square minus 15 divided by 2x minus 3. So we get 3x plus 5. There is a quotient because remainder we got 0. Okay. So I'll explain some more big number. You'll understand more clear. So let me take one question here. Let me solve here. Okay, see here for example. So find the quotient and remainder here now. So when it is divided by x to the power 5, x to the power 5 plus 3x to the power 4 minus 5x cube plus 14x square plus 36x minus 13. Now this I should divide by x square. So question is already in order. So I'm writing that solution part. X square plus 4x minus 2. Now find the quotient and remainder. Both we need to find out. Okay. So we'll solve the method by first x square. First term in this divisor and first term in the dividend is x power 5. X square into dash is x to the power 5. That is x power 3. Okay. X square into x power 3 is equal to x power 5. We know it. Now take this x cube. Okay. Take this x power 3. Multiply each and everything in this divisor and write down. This is the first step. Same multiplication with the polynomial by monomial process. X cube into x square is x to the power 5. Again x cube into 4x, that is 4x to the power 4 minus x cube into 2 is 2x cube. Okay, it's the first step. Then subtract it, then change the sign if you need. It will be get cancel. Plus 4x power 4 is minus and this is plus. Okay, 3 minus 4, so minus x to the power 4 minus 5 plus 2 is minus 3 x cube. Now take one term down. Next term if you take down, that is plus 14x square. One term only it can take down. Now the again method is same. So what's the method? X square is the first term in this divisor and minus x power 4 in this dividend place now. So x square into dash is minus x power 4. You can check in roughly. Now let's see. X square into dash minus x power 4. That is minus x square. Because minus x square into x square is minus x to the power 4. Now take minus x square and multiply each and everything in this divisor. Okay, minus x square into plus 4x is minus 4x cube. Again minus into minus plus 2x square. Everything I multiplied. Okay, change the sign and do addition. So this becomes plus, so it get cancel this first term and minus 4x cube becomes plus, so that is x cube, and this changes signs minus, plus 14 minus 2, that is plus 12 x square. So next term is 36x. Take this 36x down and write here plus 36x. Again the method is same, just continuing the method similarly. X square into dash is x cube, that is plus x. Okay, now take this x. Okay, x square into dash is equal to x cube, that is x. So x, now take this x and multiply these three terms one by one and write down. So that is x cube, again x into 4x plus 4x square, again x into minus 2 is minus 2x. Okay, now change the sign. If it is minus sign, get cancelled. If it is minus, 12 minus 4 is 8x square, 8x square, and if change the sign, it's plus 36 plus 2 is 38 plus 38x. Now last and final term is here, we take down minus 13. Okay, now again the process continue the same. X square into dash is 8x square, so obviously plus 8. Okay, so plus 8. Now take this 8 and multiply each and every term in this divisor, that is 8x square, 8 into 4x, 8 4s are 32x, again 8 into minus 2, that is minus 16. Okay, each and every term we multiply. No more terms to take down. Now change the sign, this becomes minus and cancel. This also should be minus. 38 minus 32 is 6x. Okay, now minus, this also change the sign, plus, minus 13 plus 16 is plus 3. So no more terms to take down, so 6x plus 3 is the remainder. Therefore quotient is, so this is the quotient now, x cube minus x square plus x plus 8, and remainder is 6x plus 3. So they are asking the problem, what's the quotient and remainder. So quotient is equals to x cube minus x square plus x plus 8, what we got, and remainder. So remainder here 6x plus 3, that's it. So only quotient if they asked, remainder will get 0. So here remainder also you got 6x plus 3. Fine. So this is the way we can solve. The highest must be written in descending order. The main important thing is, if any variable, any power is missed, we can keep x to the power 0. For example, here x cube is not there, means you can just keep 0 into x cube in case the term is not given. So such type of problems also, so I am showing in this website. So this is the way we can do division. And apart from these problems only, we have some more questions and some more materials also, as I explained starting. So I am showing on a website here. In this website, providing link also in description below, just click on that, and class 8th, other subject, other material also can available. So different questions also available with the different model papers and test papers, so you can go through it. And the important thing is, in case if you did not subscribe, please subscribe this, because we'll upload only videos which are related to the education, so it's very helpful for you.